Now electrolysis. What is meant by electrolysis? Electrolysis means breaking down of ionic compound when molten or in aqueous solution by the passage of electricity. Usually this question comes in the exam out of 2 marks. 1 mark to say breaking down of ionic compound and 1 mark to say by passage of electricity. And we have another definition. What is meant by electrolyte? Electrolyte means a liquid that conducts electricity, and the liquid itself will undergo electrolysis. So the liquid itself will be electrolyzed. If the liquid can conduct electricity and will be electrolyzed, like ionic compounds, molten ionic compounds or dissolved ionic compounds, so these are electrolytes. But if the liquid doesn't conduct electricity, like ethanol, it will be non-electrolyte. To understand better what is meant by or what happens in electrolysis, here are the basis of electrolysis. In electrolysis, we use rods or electrodes like these. These electrodes made of graphite or platinum, because graphite and the platinum are inert, so they will not react with the electrolyte. Right here we have example like lead bromide. Lead bromide is ionic compound, but it doesn't conduct electricity if it's a solid, so it should be molten first to be liquid to can conduct electricity. So here we heat it and to be liquid. So we have here molten lead bromide. This molten lead bromide, when electricity passes through it, it will be broken down into lead and bromine. This is called electrolysis. Electrolysis is electrical decomposition reaction, means the compound will be broken down with electricity into elements like this. Usually you will see the metal forms at the negative electrode and the non-metal forms at the positive electrode. Here lead bromide, lead is positive ion, bromide is negative ion. The positive ion will be attracted to the negative electrode, and the negative ion will be attracted to the positive electrode. Remember this Pa means positive anode. So the anode is positive and the cathode is negative. So we call the positive electrode anode, the negative electrode cathode. And remember RAC means reduction at cathode. So reduction at cathode and oxidation at anode. So at the cathode, reduction happens, at the anode, oxidation happens. So now the positive ion lead will go to the negative electrode, and at the cathode, as you know, reduction. So reduction happens for lead. So this means lead will gain electrons. Lead will gain electrons. Lead ions will gain electrons to be pure lead, to be neutral lead. So lead will deposit here. And negative ions like bromide will lose electrons to change to be bromine. So bromine forms here as bubbles at the positive electrode. In this way, lead bromide is broken down. So remember that reduction happens at cathode and oxidation at anode. You can remember this using RAC, reduction at cathode. So it's a reduction at cathode here and oxidation at anode here. So this is example of electrolysis of molten ionic compound. What's about dissolved ionic compounds in water? Here we have electrolysis of aqueous solution. Aqueous solution means the ionic compound is dissolved in water. So the solution may be concentrated and may be dilute. For example, if you have concentrated sodium chloride solution, this is called brine. Brine is concentrated, very concentrated sodium chloride solution. So here actually you don't have only sodium chloride, you have also water. And this water is made of hydrogen ions, positive hydrogen ions and the negative hydroxide ions. So if you have now sodium chloride with water and you do electrolysis, what will happen? Actually you have positive sodium ion and the positive hydrogen ion. Both of them will be attracted to the negative electrode. And you have negative hydroxide ion and the negative chloride ion. Both of them will be attracted to the positive electrode. So at the negative electrode, which is the cathode, which one will gain the electron and will be reduced, hydrogen or sodium? Actually hydrogen. Why? Because the rule says the more reactive positive ion stays in the solution, but the less reactive will gain the electrons and will be reduced. And you know from the order of reactivity, you know from the reactivity series, that sodium is more reactive than hydrogen. Hydrogen is less reactive down. So the ion which is less reactive will gain the electrons. So hydrogen will gain the electrons and will be reduced into hydrogen gas. So when we do this electrolysis, you will see hydrogen bubbles here. And the negative ions now, hydroxide ions and chloride ions. These are negative ions will be attracted to the positive electrode. So which one will lose the electrons and which one will be formed? The rule says if you have halogen, halogen forms. If there is a halide, halogen forms. If there is no halide, oxygen forms. So because we have a halide here, which is chloride, so chloride will be oxidized and will it change to be chlorine. So chloride negative ions will lose the electrons, its oxidation, and will it change to be chlorine gas. So you will see chlorine bubbles here at the positive electrode. So that's in case if you use concentrated solution. But what's about dilute solution? If you use dilute solution, so you have too much water. You have too much water and few salt. So the salt will not be electrolyzed in this case. Only the water will be electrolyzed. So if you have dilute solution, only the water will be electrolyzed and it will be broken down into hydrogen and oxygen. The water is H and OH. H positive will gain electrons and it change to be hydrogen gas, and the hydroxide will lose the electrons and will it change to be oxygen gas. So this happens with the dilute. Let's take other examples of concentrated solutions. If you have a concentrated solution of potassium bromide, so actually you have potassium bromide and water also. Water is hydrogen and hydroxide. So you have here positive potassium, positive hydrogen. So both of them will be attracted to the negative electrode. And bromide and the hydroxide, both of them will be attracted to the positive electrode. So right here, potassium and the hydrogen, which one will gain the electrons, which one will be reduced? It's a hydrogen because it's less reactive than potassium. So potassium ion, because it's more reactive, will stay in the solution, but hydrogen, because it's less reactive, will gain the electron and will change to be hydrogen gas, hydrogen bubbles. Now, between the negative ions, which one will form? The rule says if you have a halide, so halogen forms. Bromide is a halide, so bromine gas will form. So if you do electrolysis here at the negative electrode, you will get hydrogen, and at the positive electrode, you will get bromine. Another example, concentrated silver nitrate solution. Now in silver nitrate solution, you have silver nitrate and water. Silver nitrate, silver positive, nitrate negative, and you have hydrogen positive and the hydroxide negative. So these positive ions, silver and the hydrogen, will be attracted to the negative electrode. So now the question is, which one will gain the electrons, silver or hydrogen? Silver is less reactive than hydrogen. So silver will take the electron, will gain the electron, and will form, and the hydrogen will stay in the solution. And between negative ions, you don't have halide here. So oxygen forms. So oxygen forms at the anode. Another example, if you have concentrated hydrochloric acid is H and Cl. In the same time, you have water because it's a solution. So you have H and OH. So actually you have only positive ions, which are hydrogen. So hydrogen here will gain the electrons, and will it change to be hydrogen gas. And between the negative ions, you have chloride and hydroxide, because you have halogen here, halide, which is chloride, so halogen forms, so chlorine gas will form. And as I told you, if you have a dilute solution, ignore the salt you have, or the acid or the base, focus only because it's a dilute, so you have too much water. So this water only will be electrolyzed into hydrogen and oxygen. Now electrolysis of brine. Brine means it's a concentrated solution of sodium chloride. So it's a concentrated solution of salt, and this salt we can get it from salt mines, from underground. By doing electrolysis of this brine, you get three products: sodium hydroxide, chlorine, and hydrogen. And here are the details. Here we put the brine, and we use here nickel cathode and titanium anode. So the cathode, it is a negative electrode. So the negative electrode will attract the positive ions. The positive ions here are hydrogen and sodium. The question is, which ion will gain the electron, hydrogen or sodium? The rule says the less reactive ion gains the electron. So hydrogen will gain the electron. And will it change to be hydrogen gas, hydrogen bubbles. So hydrogen bubbles form here at the cathode. And right here we use titanium anode. Titanium anode, it's a positive electrode, will attract the negative ions. The negative ions are chloride and hydroxide. The question is what we will get, because we have a halogen here, so halogen forms. So chlorine bubbles form here at the anode. And we use a membrane in between. This membrane lets ions through but keeps the gases apart. So we don't want these gases to be mixed. So we use a membrane to separate the gases from each other. So here we get chlorine gas, and here we get hydrogen gas. And what remains in the solution? Sodium hydroxide, because sodium ions will stay in the solution and hydroxide ions also. So you will have here sodium hydroxide. So as we said, you have three products: hydrogen gas by reduction, chlorine gas by oxidation, and sodium hydroxide ions stay in the solution. So by doing the electrolysis of brine, you have three products: chlorine, sodium hydroxide, and hydrogen. As you know, chlorine is poisonous, yellow-green gas. Sodium hydroxide is alkaline and corrosive, can burn the skin, dangerous. And the hydrogen is a colorless, flammable gas. So all of them are dangerous. Chlorine poisonous, sodium hydroxide corrosive, hydrogen is flammable gas. So they should be stored safely and transported safely. Here we have the uses of chlorine, sodium hydroxide, and hydrogen. The uses of chlorine, it's used to make PVC, polyvinyl chloride. It's a plastic, and chlorine is used to make solvents, medical drugs, weed killers, paints, bleach. As you know, of course, chlorine is used as bleach. And it's used to make hydrogen chloride gas and hydrochloric acid. And of course, as you know, chlorine is added to swimming pool water to kill bacteria. So it's a sterilizing agent. Now the uses of sodium hydroxide. Sodium hydroxide is used in making soap and detergents and rayon, textile, and papers, ceramics, dyes, and medical drugs. Hydrogen gas can be used to make nylon and hydrogen peroxide, and to harden vegetable oil to make margarine, and as a fuel. As you know, hydrogen gas is a fuel, can be used as a fuel in rockets because it burns with oxygen, making heat, and it also can be used in hydrogen fuel cell. Okay, right now we talk about the electrodes. We can use inert electrodes and we can use reactive electrodes. And we will get different products. So first, for example, now if you have copper sulfate solution, If you do the electrolysis of copper sulfate solution using graphite electrodes, inert electrodes, you will get products. But if you use copper electrodes, you will get different products. So the products will be different depending on the kind of electrodes we use. First, if we use inert electrodes like graphite or platinum, here you have copper sulfate solution. Copper sulfate solution, so you have copper sulfate and water. You have copper positive ion and the hydrogen positive ion. Both of them will be attracted to the negative electrode. And between both of them, which one will gain the electrons? As you know, the less reactive will gain the electron. Copper is less reactive, so copper will gain the electron, will be reduced into pure copper. So copper will deposit here on the negative electrode. Copper deposits here on the negative electrode. طيب, what's about the negative ions? You have sulfate and hydroxide. The rule says if you have a halide, halogen forms, but if you don't have a halide, oxygen forms. So here we don't have a halide, so oxygen forms. So what happens? These hydroxide ions, the negative ions, are attracted to the positive electrode and will be oxidized, will lose the electrons. So hydroxide will change to be oxygen, water, and 4 electrons. You can memorize this equation like this. 4 hydroxide will make 1 oxygen, 2 water, 4 electrons. So 4, 1, 2, 4. Okay? That's if we use inert electrodes like graphite and platinum. But platinum is more expensive than graphite, so it's better to use graphite to save money. Type. What's about if we use copper electrodes? If we use copper electrodes, we will have different reactions here. Why? Now we will not focus on the electrolyte itself. We will focus on the electrodes. Here you have the positive anode is copper, and the negative anode is also, and the negative cathode is also copper. So both of them are copper. So what happens? The anode, which is positive, this anode here is copper. Copper will dissolve. Remember that we said before RAC. So RAC means reduction at cathode and oxidation at anode. So at the anode you will have oxidation. Copper will change to be positive copper ion and electrons. So copper here loses electrons. Copper here loses electrons. As we said before, RAC means reduction at cathode. So at the cathode you have reduction, at the anode you have oxidation. So at the anode here, copper will be oxidized, will change to be positive ion and the electrons. But at the cathode, copper ions in the solution will gain electrons and it change to be neutral copper. So copper will deposit on the cathode. So right here again, you have both electrodes are copper. Both electrodes are copper, and the solution already is copper sulfate solution. So what happens? At the anode you have oxidation. So copper dissolves in the water, it's oxidation. Copper will be oxidized, and these copper positive ions will go to swim in the solution and will be attracted to the negative cathode. At the negative cathode, reduction happens. So copper ions will gain the electrons and deposit, and they change to be neutral copper that will deposit on the cathode. So over the time, the anode mass will decrease and the cathode mass will increase. Why? Because over the time the anode dissolves and copper deposits here on the cathode. We can use this idea in refining copper, in purifying copper. We can put impure copper as anode and pure copper as cathode, and we do electrolysis. So what happens? Copper atoms will be oxidized into copper positive ion and the electrons. So the copper positive ions will dissolve in the solution and will be attracted to the cathode. At the cathode, copper positive ions will gain electrons, will be reduced and deposit here on the cathode. In this way, the copper will go from the anode to the cathode. So you will get pure copper here at the cathode. It's a 99.9% pure copper at the cathode. What about the anode? Only the impurities will remain at the anode, and these impurities do not dissolve. They just drop to the floor of the cell as a sludge. Then these impurities can be recovered and sold. Remember here that when we use inert electrodes like carbon and the platinum, copper sulfate here is electrolyzed. So the blue color of the copper sulfate over the time will fade, will change to be colorless. Why? Because copper sulfate it changes to be pure copper and oxygen, and copper sulfate solution will change into pure copper and oxygen gas. So the blue color fades over the time here. But right here, with using copper electrodes, actually the amount of copper will change to be ions equals the amount of the ions that will change to be copper again. So the concentration of copper ions in the solution here will not change. So the blue color here doesn't fade. The last point in this chapter is about electroplating. Electroplating, it's a use of electrolysis. So now we have two uses of electrolysis, refining copper and electroplating. Electroplating means we use electricity to coat one metal with another. For example, here we have this jug. This jug is dirty and we need to make it looks better. So we need to coat it or paint it with or plate it with silver. So what we do, we connect the jug to the negative terminal of battery, so it's a cathode, and we put here silver as anode. As you know, silver can be oxidized into positive silver and electron. Then this positive silver ion will swim in the solution and will be attracted to the cathode, the negative electrode, the cathode, and at the cathode the silver positive ion will gain the electron, will be reduced and deposit as silver on the jug. So again, what is the idea? We use silver anode, the silver here dissolved in the solution as ions, and the ions here will gain the electrons, and the silver will deposit over the jug. In this way, we plate the jug. So this is called electroplating. Remember that to electroplate, the cathode should be the object that you want to electroplate, and the anode will be the silver or gold or copper, the metal you will use for electroplating. And the electrolyte should be a solution of soluble compound of this metal. And if you, for example, if you use silver here, the solution should be silver nitrate or silver salt solution. If we use gold here, so the solution should be gold salt solution, like this. We can use this electroplating here to electroplate this water tap. This water tap is a steel tap, so we can plate it with chromium using electroplating. But remember that chromium doesn't stick well to steel, so first we can electroplate this steel with copper or nickel, then we electroplate it with chromium. This lesson 14.4, extracting aluminum, is part of our syllabus because it's talking about electrolysis, and we study electrolysis. So here we talk about extracting aluminum, how to extract aluminum by electrolysis. Aluminum is found in nature as bauxite. It's found in the ore of bauxite or the rock of bauxite. Aluminum is found as aluminum oxide in the rock of bauxite. So now we have aluminum oxide and we need to extract aluminum from it. So we need to change aluminum oxide into aluminum. The question is how? By electrolysis. So here Aluminium oxide with electrolysis will be broken down into aluminium and oxygen. So how can we do this? First, we get bauxite ore or the rocks of bauxite that contains aluminium oxide. This bauxite is red brown in color because it has some impurities, but when we remove the impurities and if we have only aluminium oxide, we will see it's white. So aluminium oxide, it's white and it's called alumina. Now we need to do electrolysis for this aluminium oxide. So we use this electrolysis tank. It contains a positive carbon electrode or graphite and negative carbon electrode or graphite. So here the electrodes are made of graphite, it's inert electrode, and we put here the aluminium oxide. As you know, to do the electrolysis, aluminium oxide should be molten, should be liquid. But we have a problem. The problem is the melting point of aluminium oxide is very high. It's 2045 degrees. So it's hard to melt it at this temperature. So what is the solution? We can mix aluminium oxide or dissolve it in molten cryolite. What is cryolite? It's a sodium aluminum fluoride we use to lower the melting point of aluminium oxide, and it also increases the conductivity. So again, aluminium oxide has very high melting point. So we need to lower this melting point. So what can we do? We mix or we dissolve aluminium oxide in molten cryolite. So the melting point will decrease to be 950 degrees. So here you have aluminium oxide dissolved in molten cryolite. So what happens? Electrolysis will happen. As you know, aluminium, it's positive, and oxide, it's negative. The positive ion will be attracted to the negative electrode. So aluminium or aluminum will go to the negative electrode, which is the cathode. And as you know, reduction at cathode. So aluminium will be reduced, will gain electrons, and will change to be pure aluminium. So pure aluminium will form here, molten aluminium will form here, and will leave from this opening. At the anode is positive electrode, so it will attract the negative ion, which is oxide. So oxide, the negative ion, will be attracted to the anode. At the anode, as you know, oxidation happens, so oxide will be oxidized. So it will lose electrons and it change to be oxygen gas. So you will see oxygen bubbles here at the anode. This anode is graphite, so it will react with the oxygen, making carbon dioxide. So again, you have oxygen bubbles react with carbon, graphite, to make carbon dioxide. So over the time, this carbon should be replaced because it will be eaten. Carbon blocks get eaten away and they need to be replaced. So in this way, we get the molten aluminium, and it's put here in these molds to make aluminium blocks. Now we talk about the uses of aluminium and the properties of aluminium. The uses of aluminium, it's used to make cans, food cartons, cooking foil, bikes, aerials, electricity cables, ships, trains, and aircraft. Why? Each use of these has a reason. The reason here in the properties. What are the properties of aluminium? Aluminium is bluish silver, shiny metal, has low density. Actually, iron is heavier than aluminium 3 times. Aluminium is good conductor of heat and electricity. It's malleable, it's ductile, resists corrosion. It's not very strong when pure, but if you mix it, if you mix it with zinc, magnesium, copper, it will be stronger in this alloy. And also aluminium is non-toxic, so it's safe to be used to store food inside. Now we need to understand why aluminium resists corrosion. As you know, aluminium doesn't corrode. So why it resists corrosion? Actually, only the outer layer of aluminium will corrode. يعني aluminium can react with oxygen to make aluminium oxide. But this happens only at the surface of aluminium. A fine coat of aluminium oxide forms on its surface, and this fine coat acts like barrier. This coat is non-porous. So if you think about aluminium like this block, only the outer layer will be aluminium oxide, but oxygen cannot go inside. So inside it, it will stay aluminium as pure aluminium. Only the outer layer will be aluminium oxide. And this outer layer is very thin, cannot be seen with your eyes. And in the same time, it's non-porous. So it doesn't have pores or openings. So will not let the oxygen to go inside. So in this way, the outer layer acts like barrier and resists the corrosion.